Hello, this is Dr. Hanaa Assil, and this is a video for AS Edexcel Chemistry. And today we are discussing the paper that was examined in January 2021. So this was one of the recent papers. Okay, the first question says, which of these compounds has the same empirical and molecular formula? Remember that to have the same empirical and molecular formula, then the ratios will be something that cannot be simplified, because empirical means a formula that will show the simplest ratios between the atoms, while the molecular formula, we say this shows the actual. So in order to have the same empirical as actual, that means we need to choose the one in which the ratios cannot be simplified. So if I have C2H4, for example, that would be the molecular formula, but its empirical formula will be CH2. But if I have C3H8, there is no way of simplifying that. So that would be the empirical and the molecular formula. The other two that we have here are things that can be simplified. So C4H10 would actually have an empirical formula of C2H5. C5H10, its empirical formula will be CH2, and so on. Okay, the next question says there are 6.02 times 10 to the 23 atoms in 0.5 mole of which of these? So we're looking for the number of atoms. How do we get number of atoms? You should realize that the number of atoms would be the number of moles times Avogadro's number. So this would be the number of atoms for helium. For water, the number of atoms would be the number of moles, but we need to multiply that by the number of atoms. Water has 2 hydrogen and 1 oxygen atoms, so you need to multiply the number of moles by 3. Then we multiply by Avogadro's number. The same for BH3. BH3 has a total of 4 atoms, so we need to multiply by 4. CH4 has 5 atoms, so we need to multiply by 5. Now, which of these gave us 6.02 times 10 to the 23 atoms? That is C. Okay, the next question says, which aqueous solution has the highest concentration in mole per decimeter cubed of chloride ions? That means we're trying to get the number of moles of chloride ions for each of these. He gives me the concentration in grams per decimeter cubed, and he wants it in mole. So we just need to get the number of moles of chloride ions. Now, number of moles is the mass over the molecular mass. So it's the 0.1 grams over the molecular mass of HCl, mass number of hydrogen plus mass number of chlorine. That comes out to be this concentration. Now, the next one will give the number of moles. We're dividing 0.1 by the molecular mass of sodium chloride, and so on. That will give the number of moles of chloride ions. For barium chloride, remember that barium chloride actually has 2 chloride ions per molecule. So if I get the number of moles of molecules, then I need to multiply it by 2 to get the number of moles of ions. Then looking at all of these answers, which one has the highest concentration? Well, HCl will have the highest concentration. Okay, which conversion has the lowest percentage atom economy? Remember, how do we get percent atom economy? The percent atom economy will be the molecular mass of the required compound, in this case it's calcium chloride, over the molecular mass of all the products. So A is something that has only calcium chloride as a product, so its percent atom economy is 100%. Remember, if the required compound is the only product, then I have 100% atom economy. For B, I need to calculate molecular mass of calcium chloride over the molecular mass of all the products. That means molecular mass of calcium chloride plus hydrogen. And times 100, of course, this is the percent atom economy. This would be the percent atom economy for C and the percent atom economy for D. and he's saying which one is lowest. Well, D is the lowest, and you should realize that the more the molecular mass of the products, the less the percent atom economy. Okay, which of these atoms has the most neutrons? Well, how do we calculate the number of neutrons? It's the mass number minus atomic number, mass number minus atomic number, and so on. Which of these has the most? Then it is B. Here he's saying a p block element in period 3 reacts to form an ionic compound. What would be the electronic configuration of the ion formed by this element? Remember that if we look at the periodic table, well, first of all, he wants a p block element. A is not a p block, A is an S block, so A is off. He wants it in period 3. Period 3, that means C and D are off. They are not in period 3. So the ones that we can choose, that is in a P block, that means it ends with P, and it's in period 3, that is B. This question says the period 2 element with the highest melting temperature. So let's look again at the periodic table. Well, first of all, we're looking for something that's in period 2. Aluminium is not in period 2. And silicon also is not in period 2. So we're looking at B or C. Now, which of these has the highest melting temperature? Well, you should remember that carbon has a giant structure, diamond or graphite, and that means that it has a very high melting point. Which of these has the greatest electrical conductivity? Okay, let's see the choices. Of course, to conduct electricity, something must be a metal or an ionic substance. Now, A and B, SF6 and H2O, these are covalent, so they're off. We cannot choose them. So my choice would be mercury, which is a metal, and that would conduct electricity. Sodium oxide, D, the one in D, is actually an ionic compound, but then he's saying it's sodium oxide solid. Remember that an ionic compound will not conduct electricity when it's a solid, so the only one that conducts electricity here actually is mercury. Which of these ions has the greatest ionic radius? Okay, let's compare these choices from the periodic table. We have nitrogen 3 minus. Nitrogen 3 minus has a total of 10 electrons. F minus also has 10, Na plus and aluminium 3 plus. All of these have 10 electrons. These ions have all the same number of electrons, so we call them isoelectronic. And he's saying which one has the greatest radius. The one that would have the greatest radius is the one that has the least number of positive charges attracting the electrons to the nucleus. So, which one has the lowest number of protons? That is nitrogen. So nitrogen has only 7 positives attracting the 10 electrons. So it will have less attraction forces and the radius will be higher. Okay, which one of these ions has the greatest polarizing power? Now remember, polarizing power means I am looking at something that is positively charged, not negatively charged. The negative charge is the one that is polarized, but the one that polarizes it is the positive charge. And to be something that has higher polarizing power, it should have more positive charges. So the one that has higher positive charges is the one that has greater polarizing power. Which of these does not have a structure formed by a giant lattice of carbon atoms? Well, let's look at each of them. What is fullerene? Fullerene has this kind of structure. It's a small molecule. It looks like a football with 60 carbon atoms arranged in a structure of pentagons and hexagons. So this is regarded as a small molecule, not a giant. Diamond, of course, is giant with many, many carbon atoms. Graphene is one layer of graphite, so it is still regarded as giant with many carbon atoms. Graphite is several layers with many carbon atoms. So the only one that is not a giant lattice is fluorine. Which of these molecules is the most polar? Well, let's look at each molecule. HF, OF2, BF3, CF4. Now remember, he's asking about the molecule itself. First of all, for a molecule to be polar, it must have polar bonds and the polarities should not cancel. So if I look at HF, there is a big difference in electronegativity between hydrogen and fluorine. So the bond between H and F is very polar. O and F, there is very little difference in electronegativity, so the OF bond will have less polarity. The BF3 and the CF4, each bond is polar, but the molecule as a whole is not polar because the polarities are in opposite directions, so they cancel. So the one with the highest polarity is the HF.
Question 13 says, a substance is labeled with the hazard symbol shown. What is the meaning of this symbol? Of course, you're required to know the meaning of all of these hazard symbols, and the one we have means what? It means corrosive, and that means it is harmful to the skin. So you'll see this kind of hazard symbol on bottles of concentrated acid or concentrated base.
Try to find the longest chain, and we start numbering the chain from the side that will give the lower number for the substituent. So in this case, we can start from 1, 2, 3, 4, 5, 6, 7, 8. And if we go the other way, it would give larger numbers for the substituent. So this is 8 carbon, so that's an octane. The substituents, I have 3 methyl groups, so I need trimethyl, and each one is on carbon 3, 4, and 6, so that would be the correct IUPAC name. Here we're looking at petrol, bioethanol, and hydrogen, and he's saying all 3 of these fuels are which of this? Well, burn to produce greenhouse gases? Yes, that's correct. They all burn to give greenhouse gases. If we say they are overall carbon neutral, no, not all of them are carbon neutral. Remember, which ones do we say are carbon neutral? They are the things like bioethanol that we get from plants, because we say the plants, while they're growing, they take carbon dioxide from the air in photosynthesis. So when we burn them and give out carbon dioxide, that is sort of not adding anything new, so that is carbon neutral. Are they overall sustainable? Remember, the word sustainable means renewable. Well, no, petrol, for example, is not regarded as renewable. Biodegrade rapidly? No, petrol also does not biodegrade. So the only one that applies to all 3 is A. Here he's asking about cyclopentane, and he's talking about free radical substitution of the pentane with bromine. Which of these is an overall equation for this reaction? First of all, cyclopentane, pentane means it has 5 carbons. But remember that the formula of a cyclic compound has the same general formula as an alkene. So something with 5 carbons would have 10 hydrogens, CnH2n, like the alkene. So A is wrong. And then if we have free radical substitution of an alkane with bromine, what do we get? You should realize that the product would be the one we have in D, which is the bromoalkane plus HBr. To remind you of this, you need to know this mechanism. This is free radical substitution mechanism in which we're reacting an alkane with a halogen. So you should remember that in the mechanism, the initiation step is the one that we need the UV light for, and the UV light undergoes homolytic fission of the bond. So the bond between the Br and Br break up so that each electron goes to one of the bromines, and this forms two bromine free radicals. Now, this goes on to do the propagation step. In the propagation step, there is another homolytic fission of the bond to remove one of the hydrogens from the alkane so that it reacts with the Br radical to form HBr, and we're left with the alkane free radical. This alkane free radical goes on to break another molecule of bromine. So not all the molecules of bromine are broken in the initiation step, only some of them are broken in the initiation step. The others are broken in the propagation step, which goes on to form the bromoalkane plus a bromine radical, and the bromine radical continues in the propagation step to give many products in a chain reaction until we reach the termination step. The termination step is one in which two of the radicals join together. So one of the possibilities would be where two of the C5H9 radicals join together to form a total of what? A total of C10H18. So this is an overall reaction. Now, what is he asking? He's saying, first of all, which statement is not correct about this reaction system? So looking at the choices, he's saying the first choice says only the initiation step involves homolytic bond fission. We said that is not correct because we have homolytic bond fission in the initiation step and in the propagation step. The others are correct. So he's saying only some bromine is converted to free radicals in the initiation step. Yes, we said some of it is broken up in the initiation and some of them are broken up in the propagation. Now, the C says propagation forms more product than termination. That is correct because remember that the propagation steps are a chain reaction in which you can have many products before reaching the termination step. Now, D says further substitution reactions are likely to occur. Yes, we said we can substitute one hydrogen and put a bromine instead of it, or we can substitute two of the hydrogens, and in that case we get a dibromo product. Okay, then he says which free radical is least likely to form in the propagation step. Well, let's take a look at the choices. C5H9 radical, yes, it can form. The Br radical forms. The C5H8 Br radical could form if we're trying to substitute another bromine for one of the hydrogens. But D, H radical, can never form in this mechanism. Which alkane could be formed in a termination step? Remember when we were going over the termination steps, we said we can end up two of the C5H9 radicals joining together. So we should end up with something that has C10H18. Well, A is not a correct answer because that's not C10. It's 1, 2, 3, 4, 5, 6, 7, 8. B also is not a C10. The answer then would be C because C is something that will give me C10H18 and D will have the wrong number of hydrogens. Okay, which of these is not a way of limiting global problems caused by polymer disposal? So which will not help to overcome the problems of polymer disposal? Remember that when we talked about polymers and we said the problems of polymers is, first of all, most of them are non-biodegradable. So developing biodegradable polymers would actually help. But exporting polymer waste, that's not something that will help to overcome our problems. Removing toxic waste gases, that's a good process that we can do. Reusing products, that would save energy, so that is a good approach. But exporting polymer waste would not help to overcome the problem. Okay, Now we're in section B. In section B, the first question says, complete the diagram to show the electronic configuration for a sulfur atom. Remember, if we look at the periodic table, the sulfur atom has 16 electrons, so we can distribute it 1s2. Remember, we need to fill the lower energy first, 2s2, 2p6, 3s2, and then I'm left with 4 electrons, and these 4 electrons will have to go 1, 1, 1 into each of the p orbitals, and then the fourth will have to be paired. So this is how we distribute the electrons. He's saying write an equation for the first ionization energy of sulfur and include state symbols. Remember that first ionization energy means I'm starting with a sulfur atom and we remove 1 electron. It becomes an S plus, and this is all in the gaseous state. Explain why the first ionization energy of sulfur is less than first ionization energies of both phosphorus and chlorine. Now, when I answer a question like that, it's better to keep in mind what is the electronic configuration of each one and how are the electrons distributed. This way you can see what is the difference between them. So he's saying we should compare sulfur to phosphorus and sulfur to chlorine. So let's take a look. First of all of them are in the same orbital. They are in the same 3p orbital, so there is no difference between them in that way. If one of them was in, for example, the 3p, the other is in the 3s, then we would say that the one in the 3p has higher energy, but all of them are in the 3p. So they all have outermost electrons in the same sublevel. So what is the difference between sulfur and phosphorus? Well, the difference between sulfur and phosphorus is the fact that the sulfur has a paired electron, and the paired electrons have more repulsion and are more easily removed, so they will need less energy to be removed. Now, comparing sulfur to chlorine, well, the difference between sulfur and chlorine is that chlorine has more protons in the nucleus, and that means there is more attraction between the outermost electron and the nucleus, so it will need more energy to be removed. The next question is saying what is meant by isotopes. Please remember the definition of isotopes: atoms of the same element having the same number of protons but different number of neutrons. Calculate the relative atomic mass from that table. Remember to calculate the relative atomic mass from the different isotopes. We take the mass number of the isotope times its abundance plus the mass number of the other isotope times its abundance, and so on, over 100. That here gives me 32.09, and then I check what is he asking me to do. He says give your answer to 2 decimal places, so that means that that is my answer. The next question says the mass spectrum of a sample of sulfur with sulfur 32 as the only isotope. That means that these peaks are not due to different isotopes, they're actually due to different molecules. So 32, the lowest m over z here, that is actually a peak due to one atom, our monatomic molecule. 64 is 2 of them, and so on. So the next question says, calculate the number of sulfur atoms in the molecular ion. Remember again, molecular ion means the one with the highest m over z. So the one with the highest m over z is 256. Now we know that each sulfur is 32, so if I have 256, that means I have 8 sulfur atoms in that molecule. So just the formula of the most stable ion. The most stable ion is the one that gives the largest peak. That's the 100% abundance. So that is 64. Now 64 is due to how many atoms together? 64 will be due to 2 atoms together. So this is how we write it. Stable ion. You must have a plus on it. All the species in the mass spectrum are positive ions. Okay, the next question says we have NCl3 and he's saying we need to find out how many bond pairs and lone pairs and so on. So the first thing I would do would be to draw the dot and cross diagrams for all of this. So you should realize that if I'm trying to draw the dot and cross, the nitrogen has a total of 5 electrons. It is using 3 of them to bond with the 3 chlorines, so it still has one pair of electrons that were not used for bonding, so that is called a lone pair. So the total number of bonding pairs, again, remember the word pairs means in twos. We have how many bonding pairs? We have 3 for each, 1 pair for each bond. How many lone pairs? Well, we have 1 lone pair on the nitrogen. What do you think would be the bond angle? Well, this is the kind of structure that we have. Remember, if I have 3 bonding pairs of electrons and 1 lone pair on the central atom, then the bond angle would be 107 and the structure is pyramidal. Okay, he's asking here, under standard conditions, phosphorus chloride is a solid made up of something that's positive and something that's negative. So this PCl4 plus cations, PCl6 minus anions. Now, antimony chloride is a liquid made up of molecules. Explain why the PCl5 has a higher melting point than the SbCl5. Remember that anything that has positive and negative would have strong electrostatic attraction forces between the positive and negative ions, while the SbCl5 is only made up of molecules, so it has weak attraction forces between the molecules that need less energy to be broken. Here he's saying draw a dot and cross diagram to show the bonding in SbCl5. Again, you look at the periodic table, Sb is in group 5, so it has 5 electrons. It's going to use 1 to bond with each of the chlorines. Again, do not forget to put the extra lone pair of electrons around the chlorine. Each chlorine has a total of 7 electrons. It uses only 1 for bonding with the Sb, so it still has 6 electrons around it somewhere. Okay, at low temperatures, SbCl5 converts to Sb2Cl10 that contains dative covalent bonds. What is meant by dative covalent bond? Remember that the dative covalent bond is a bond in which the shared pair of electrons are coming from the same atom. Okay, complete the diagram to show the dative bonds. So where would the dative bonds here be? Remember that dative bonds would have to be electrons that are donated by one of the atoms. Remember that each chlorine has 3 lone pairs of electrons around it that's not doing anything. So each chlorine, between the 2 molecules, the chlorine will donate electrons to the Sb of the next atom, while the chlorine of that atom will donate to the Sb of the other. So these would be the 2 dative covalent. Now he's saying arsenic also forms pentachloride. All of these are in group 5. Give one possible reason why nitrogen is the only group 5 element that does not form a pentachloride. If we look at nitrogen, you should realize that nitrogen is a small atom. It cannot expand its octet. Do you remember the meaning of octet? Octet rule says that each atom needs 8. But we said some atoms will expand their octet and will have more than 8 electrons around them. Nitrogen cannot do that because it's a small atom, and if we put too many electrons around it, there will be too much repulsion between them. Okay, this one says write an equation for the incomplete combustion of 1 mole of propene to form carbon dioxide, carbon monoxide, carbon, and water. Okay, so first of all, you should realize combustion means reaction with oxygen. He's saying 1 mole of propene, that means I'm not going to put any coefficient before the propene. He says it gives carbon dioxide, carbon monoxide, carbon, and water, and then you need to balance. And remember that he says include state symbols, so propene you should know is a gas. You should realize that alkanes and alkenes with a small number of carbons, 1, 2, 3, 4, sometimes 5. These are gases. And then oxygen, of course, is a gas, carbon dioxide is a gas, carbon monoxide is a gas, and carbon, of course, is a solid, water is a liquid.
Then question B says, state one similarity and one difference that would be seen when propene is mixed with separate samples of acidified potassium manganate solution and bromine water. So we have an alkene, and you should know that the alkene reacts with potassium permanganate and bromine water. Now, when we have an alkene and we react it with bromine water, the bromine water changes from orange to colorless. Now, if we're reacting it with potassium permanganate, it changes from purple to colorless. So the similarity here is that both solutions become colorless, but the difference is the potassium manganate changes from purple to colorless, while bromine water changes from orange to color.
Okay, here he's saying propene reacts by addition polymerization to form polypropene. Draw the structure of polypropene showing 2 repeat units. Usually to draw the polymer, it's a good idea to keep in mind what the monomer looks like. So this is actually propene. Now to draw its polymer, we said remove the double bond, make it into a single bond, put a bond before it and a bond after it. So this would be the polymer. And please remember, if he wants 2 repeat units, you should give him that. This question says propene reacts with bromine monochloride to form this product. Complete the diagram of bromine monochloride to show the dipoles. What do we mean by dipoles? Dipoles means I need to see which one is more electronegative, and I give it a slightly negative charge. The one that is less electronegative will have the slightly positive charge. So of course chlorine is more electronegative than bromine. Then he says, draw the mechanism for formation of 1-bromo-2-chloropropane. So this is the reaction between propene and the BrCl. Remember, this is, if he asks what is the name of this mechanism, it's an electrophilic addition reaction. And the first step is the electrons in the double bond attack the Br plus, while the electrons in the bond between the Br and Cl will go to the chlorine. This will give a carbocation, and we said, where will the bromine attach and where will the carbocation be? Remember that the carbocation has to be a secondary carbocation that is more stable than the primary. So the Br is attached to the carbon that has more number of hydrogens. So the CH2 on the end at the left, I attach the bromine to it so that the carbocation or the carbon with the positive charge is a secondary. Remember, secondary means that that carbon is attached to 2 other carbons. Now, after that, the Cl has the electrons that were in the bond, so it has an extra negative charge, and these electrons attack the carbocation, and that ends with the required product. Here he's saying propene reacts with steam, and he's saying complete the mechanism. Again, this is the same mechanism. The double bond attacks the H plus and forms a carbocation, and then the OH2 from the water, the electrons on the oxygen will attack the carbocation, and then we're going to remove that extra hydrogen, so that will be an H plus. Okay, this is a question about production of squalane, a liquid alkane, which occurs naturally in human skin and is used in cosmetics. So he's saying suggest 2 properties that make squalane useful in cosmetics. Of course, if this is something that is, first of all, if it's an alkane, it's inert. It does not react with your skin. And then if we put it on our skin, that means that it is not toxic. It cannot be toxic and you're using it as a cosmetic. So whether it's inert or unreactive, colorless, odorless, because alkanes usually are colorless and odorless, and non-toxic. Any of these two would be the correct answer. Give the molecular formula of squalane. That means you're going to count the number of carbons, the total number of carbons, and it's an alkane. So even if you don't sit down and count the hydrogens, you should know that it is general formula CnH2n plus 2. So these are 30 carbons, and the formula is C30H62. Okay, here he's saying squalane can be produced from squalene and alkene by reaction with hydrogen. So he's talking about reaction of an alkene with hydrogen gas. Give the name of a suitable catalyst. Remember that to add hydrogen to alkenes, we can use nickel as a catalyst, or platinum would also be a correct answer. Then he's saying squalane used in cosmetic products must contain no more than 0.2 parts per million by mass of catalyst. Calculate the maximum permitted mass of catalyst in a product containing 50 grams of squalane. Again, how do we calculate parts per million? You should remember the mass of something. So we're talking about mass of catalyst over the total mass, which is 50 grams of the squalane, times 10 to the 6, that would give you the number in parts per million. So here we're looking for the mass. The mass would be the 0.2 times 50 over 10 to the power 6, and that means that I need 1 times 10 to the minus 5 grams of catalyst. That will be the maximum allowed mass. Then he's saying a reactor at 200 degrees Celsius contains 8,500 mole of liquid squalene and hydrogen gas at a pressure of this. Under these conditions, the complete hydrogenation of squalene requires 500 meter cubed of hydrogen gas. Calculate the number of C double bond C in the molecule. Remember, when we want to find out how many double bonds, we are basically looking for the number of moles of hydrogen gas, because each double bond in an alkene requires 1 mole of hydrogen gas. So we're basically trying to get number of moles of hydrogen gas. Now, how do we get it? Number of moles is the PV over RT, because we have a specific temperature and specific pressure. So the pressure here is 4 times 10 to the 5 times the 500 meter cube, because this volume should be in meter cubed as it is, over 8.31 times the temperature. Remember, the temperature has to be in Kelvin. If he gives it to me in degrees Celsius, I have to add 273 to convert it to Kelvin. That means that the number of moles of hydrogen is this number. And looking at the information, he says 8,500 mole of squalene needs this number of moles that we calculated. So 1 mole will need how many? With a simple cross multiplication, that means I will need 6 moles of hydrogen, and that means that I have 6 carbon-carbon double bonds. Here he's saying write the equation for complete hydrogenation of squalene to squalane. Remember that the squalene would have less hydrogens. Now, how many hydrogens? We just found out that it has 6 double bonds, and that means it will need 6 moles of hydrogen in order to give us the squalane, which we already know is C30H62, and that means the formula of squalene must be C30H50. Do you understand how we got that? We know that it is something that is less from the C30H62, it is less by 6 moles of hydrogen. So it is less by 12 hydrogens. Okay, the next question says globally 2.8 million decimeter cubed of squalene is used each year. Traditionally, squalene was obtained exclusively from shark liver oil, which is a mixture of liquids. And he's saying that the liver of a shark yields 300 grams of squalene. That means that each shark gives us 300 grams of squalene. Now, suggest the name of the suitable technique to obtain squalene from the shark liver oil. At the top here, he's saying the shark liver oil is a mixture of liquids. So how do we separate a mixture of liquids? By fractional distillation. Then he's saying calculate the minimum number of sharks that would be needed to produce 2.8 million decimeter cubed of squalene. Okay, now that means that I need to get a mass of squalene. The mass is what? How do I get mass from this information? Well, using the density. Density is mass over volume. So mass is density times volume. But then I have the density is 0.86 gram per centimeter cubed. Now he's saying I have 2.8 million. First of all, 2.8 million means 2.8 times 10 to the 6, but that is in decimeter cubed, so I have to convert it to centimeter cubed, and that's why I have to multiply by 10 to the 3. And that means this is the mass that I get, 2.408 times 10 to the 9. Then I have to get the number of sharks. He says each shark will give me 300 grams. So this mass will be from how many sharks we divide by 300. And that means I have this whole number, lots and lots of sharks. Many large corporations now use squalane obtained entirely from plants. Squalane can be obtained from cornstarch with a yield of 23% by mass. So that means if I have a certain amount of cornstarch, I will get only 23% by mass of squalene. The production of 1 ton of cornstarch requires 0.093 hectares of land, and he gives me at the bottom what this hectare means. It means 0.01 kilometer square. Now calculate the area of land in kilometers squared required to produce 2,500 tons of squalane. Again, a ton is 1,000 kilograms. So what do we need to do? First of all, I need how much? I need 2,500 tons of squalane from the cornstarch, but then the cornstarch gives me only 23% by mass. 23% by mass means if I have 100 grams of cornstarch, it will give me only 23 grams of squalane. So how many grams of cornstarch would be needed to give me 2,500 tons of squalane? This is the number, so this is in tons. Then we need to determine how much land is needed. He says 0.093 hectares produce 1 ton of cornstarch. So how much, if I convert it to kilometers squared, will give me 1 ton, and how much of these will produce the number of tons of cornstarch that we need? That means the area of land that I need is the 0.093 times 0.01, so that I get it in kilometers squared, times the number of tons of cornstarch that I need, so that ends up with 10 kilometers squared of land that is needed. Okay, this one says the E isomer of this compound can also be obtained from cornstarch. Explain why this exhibits geometric isomerism and has only 2 geometric isomers. Remember, to obtain geometric isomerism, I must have double bonds with 2 different groups on each carbon. And when this is present, there is restricted rotation around the double bond. So why do we have geometric isomers? Because there is restricted rotation around the double bond. The carbons must be attached to different groups. So if we look at this compound, only the double bond in the center has the carbons attached to different groups. The others have the same groups on one of the carbons or on both carbons. Then he says, draw the skeletal formula of the geometric isomer, giving a reason why this is named the Z isomer. Remember that the Z means it's a cis, so I need to turn around that double bond in the middle, and this is because the groups with the higher priority are on the same side of the double bond, and that's why we call it a cis or a Z isomer. Okay, this one is talking about structural isomers. State what is meant by structural isomers. Remember, they are compounds having the same molecular formula but different structures. Now he's saying state the number of geometric isomers of this compound. Remember that every double bond has two isomers. So basically, if we draw the compound again, we're looking for how many double bonds that have different groups attached to each carbon. I have two of the double bonds in the middle. The ones on the end, on the left and on the right, will not have any geometric isomers because the carbons are attached to the same um, groups. Now I have two double bonds that can have geometric isomers. That means I can end up with a total of four geometric isomers. This is the last question. He's saying complete the diagram to show another structural isomer of C15H24. Remember, this is something that will have a double bond somewhere. So actually, we have many possibilities. We can put the double bond here or in many, many other possibilities. And that's the end of this paper. I hope this is useful to you. Please revise all the topics and thank you for listening.